Now I welcome Dr. Rakesh Kumar Sharma, Associate Professor, Department of Chemistry, Indian Institute of Technology, Jodhpur. Dr. Sharma completed his graduation and post-graduation from University of Rajasthan, Jaipur, and has awarded PhD from Department of Inorganic and Physical Chemistry, Indian Institute of Science, Bangalore. He completed his postdoctoral research from the Ohio State University, Columbus, USA. He has also contributed as research assistant at CSIR's Central Salt and Marine Chemicals Research Institute, Bhavnagar, and senior research chemist at Zydus Cadila Research Center, Ahmedabad. He received Outstanding Research Award 2018 and Best Faculty Award 2014 from IIT Jodhpur. He has done specialization in catalysis, environmental remediation, and energy. Dr. Sharma has completed various sponsored research projects and consultancy projects. He is reviewer of many reputed journals and has international collaboration with many professors from UK, Portugal, New Britain, and Russia. Dr. Sharma is a member of many professional societies and national committees like American Chemical Society, Canadian Chemical Society, National Green Tribunal Monitoring Team, Government of India, and KARY Expert Committee, Government of Rajasthan. He has 7 patents and 48 papers in referred journals and has given many invited talks in international conferences. I once again welcome Sir for your presentation on Rajasthani clay for environment and energy application. Welcome, Sir.
Thank you very much. Am I audible?
Yes, sir. Yes, sir.
Yes, sir, audible.
Okay, thank you very much, Dr. Thank you very much, Sudaja, for the nice introduction, and thank you very much for inviting me, Dr. Upadhyay, for this webinar. I'm going to share my slides. Yes. Is it visible?
Yes, sir. Yes, sir, it is visible.
Okay, full screen. So when we talk about Rajasthani clay, we never talk about the chemistry, and we never talk about that clay can be an important material for solving various issues. The most interesting part of this that clay never has been considered as a precious material as well as a chemical for the applications. And our group has the first one who has keenly looked into the chemistry of the clay. And so what I am going to do that rather than going in very advanced, there has been some disturbance on background. I will appreciate if some please put up your mic. So our group is the first one who started looking for the chemistry. So I'm going to go very fundamental of a clay, that how clay has been formed and why it is so important material for solving important problems of different type of environment and energy applications. So when we talk about the natural clay, we normally say that what is the chemistry and what makes clay real for the different applications, and how the clay can be utilized for the various applications like the biofuel, value-added product, environmental remediation, and energy storage. So with that, I'll start this very simple thing that there has been a lot of confusion about the clay. So basically, clay is the finest particle of sand. So when you talk about the sand is rather largest one, and then silt, and then the clay. And the sand, to converting sand to clay is a chemical process that we have developed in IIT Jodhpur, and in fact, we have patented that part also. And now we are able to prepare nowadays around 100 kilogram clay catalyst and supplying to various industries. with this new developed method. It's a very simple method, but we have done a lot of study on the clay to understand the nature of the clay before deciding what chemical application has to be applied on that. So when you say, when we normally give a talk on the clay, people always confuse that what is the origin of clay and how the clay comes from, how clay forms. So I'll tell you a very simple thing, that clay has been forming in all planets, not only the Earth. And it's a very simple process, and it's a natural process where the rock and water react with each other and form the clay. For example, there's a carbon dioxide gas that can dissolve in water and form carbonic acid, which will become hydrogen and hydrogen ion and the bicarbonate ion. And that this bicarbonate ion and the hydrogen ion react with the feldspar, and feldspar convert into the clay, which is the kaolinite clay. And this is the process which is a natural process which is making different type of clay depending upon the hydrogen ion concentration and different minerals available, because the hydrogen ion will react with the different minerals and different source of the hydrogen ion which we are going to get. So the basic unit of a clay can be considered like this. It's a silicon, you know, everybody knows silica oxide, and you know, it have the tetrahedra. So tetrahedron and tetrahedra, it's a plural form of the tetrahedron. So multiple tetrahedra joining to each other to make the silica oxide, and silica oxide is a common you can see around you all the time. Now, there's another things come up in, which is the Gibbsite sheet, which is have the aluminum, which is Al2O6. It's an octahedral structure. So it's a combination of the octahedral and tetrahedral, and which might be having some small metal particles, or sorry, the metal ions in between, which will make the entire clay structure. So let's see how they look like. So this silica sheet and tip up and tip down, and then octahedral sheet and Gibbsite sheets. And then they are the layers one after another, and they are making the clay. This you can easily understand when in the villages people are cleaning the utensils using the clay or the sand, because sand has a layered structure and it can easily remove the dirt and you know the whatever the utensils are having the food particles and other things. And the same thing, we are using the clay, which is mixture with you know pitambari, that we are cleaning the utensils for the puja and other things, metal. So this is all layered. This layered with the octahedral tetrahedral combination is make very unique material of the clay. We never thought about the chemistry, but we have been thinking, and from last 10 years we are focusing on this particular mineral. And then so it is like kaolinite is the clay which is having, like you have the aluminum, which is octahedral, and then tetrahedral, and then octahedral, tetrahedral, and they are this is the one layer, and this is the another layer, and there's a interlayer distance, which is we call D, and that is make a clay. And now the combination of this and the minerals which are inside between the layers are giving the varieties of the clay. People might have magnesium, potassium, sodium, and then you can change the layers, and then you put another minerals inside or metal ion, and then it will change the entire dynamics of the clay property. And there's another halloysite clay. In halloysite clay, there's most of water molecules between two layers. That's the halloysites. So this is the moistened clay, or you can say the wet clay. These are the clay which hold the water for prolonged time. And this type of clay is good for the cultivation, because they can hold the water for a long time, which is required for the plantation. And then another is the Montmorillon. This clay is one of the most important because it's completely ordered clay. It has water plus cation inside. This cation can be replaced by another cation. You can take a better cation. So these are the film-like structure. This is called the Montmorillon clay, and this has been a widest application, and our main focus towards this particular clay. And then an elite clay will have the mica structure. So it have the mica structure. That means have a aluminum, magnesium, and iron between the layers, and there's a potassium also. So they can easily slip on each other. So they have very fine film layers, which is the flaky shape of the particular clay. And there's the vermiculite clay. This vermiculite clay having the cation, magnesium, and the uh, calcium, and little lot of water in between. And these are clays normally found in our Rajasthan area where the high saline water is found because there are a lot of calcium carbonate exists inside and calcium oxide exists inside. And these clays are also important to understand the entire dynamics of the clay when we are looking about the property of the clay for a certain application. So in general, if you have the kaolite clay, light clay, and the Montmorillonite clay, there is a simple difference. In the kaolite clay, there's hardly anything in between the layers, so they are very much compact. And then the light clay is having the potassium in between, and then Montmorillonite have the water plus exchangeable anion. Since it have the exchangeable anion, the Montmorillonite have the maximum of application for the different industrial purpose. Uh, so this is the atomic structure of light clay that you can see. This is octahedral, tetrahedral, and then tetrahedral. So this is make an entire layer. And then there's a Montmorillonite in which you have the exchangeable cation, and there's a moisture in between. Now, so how to identify of a clay mineral? So clay mineral can be done by XRD, and you can have the DT analysis. And so when you will heat at a certain rate from 10 to 1000 degrees centigrade, you have the water loss, you have the layer reorganizations, and then you have the endothermic and exothermic process by you can understand what the chemical processes are happening in the clay mineral. And then also in the Dept continuous, which you have the melt or the crystalline. So this is a typical way by which you can find out the exothermic reaction or endothermic reactions are happening. When this endothermic reaction, will have the melt curve, and then you have the exothermic reaction, or the crystallizes, you have the exothermic reaction. Now the important part is that whenever we talk about the clay, we have to talk about how the clay interact with the water. Because if the water and clay interaction is basically decide the fate of clay and type of clay. And then you can see if we are in the Western Rajasthan, we have a lot of salinity in the water, underground water. The clay property is different then, but we are going to certain another part of the world, like we have collected the clay around 35 different countries across the world. And then we found the fundamental structure of clay is same, but only thing is that the water quality around that clay is decides how the clay structure is and what minerals it exists inside. So we have taken all clay separately, and then we have done some chemical process and bring out on the same level. So only thing is that if you remove the particular cation, anion, and then do the chemical processing, it eventually come up with the similar type of clay mineral or the clay structure. So origin of charges. So the important part that when the water absorbs in the clay, there's a most important part is that it's a clay has the charges. How the charge come from? Because I'm talking about we are taking aluminum, which is octahedral, aluminum hydroxide, and another is silica oxide, which is the tetrahedral. Now you can say aluminum is +3 and silica is +4, so there's a charge difference, and the charge difference create a positive charge. And this positive charge is attracted, and this water is attracted because of this positive charge. The oxygen is negatively charged and it will attract with this charge difference. So it is basically make a completely electrostatic force has been generated, and this electrostatic force is responsible for attracting the water and different type of cations. Now you can understand easily that if this electrostatic force is used for exchange of the different cation and anions, that will help design the entire clay structure. Hello. Am I audible?
Sir? Hello, sir.
Am I audible?
Yes, sir. Yes,
Yeah,
sir.
I'm audible
Yes, sir.
because there was some notice has come that the connection has broken.
No,
That's the
now,
reason.
now you are audible, sir. Thank you.
All right, fine. So the broken edges of a clay is having the oxygen, and if you cut the edge, and then you have the remove the oxygen, and then you are going to change to a different charge distribution in the clay, and that charge distribution will be responsible for many catalytic activity, and then we have to do very, very selectively, and that's what we have been doing. So the proton then I think, okay. So the proton equilibria or the pH dependent charge. So when you change the pH of a clay processing system, that also change the entire charge difference, and this changing the pH will also change the property of the clay. So you can see simply that you have the positively charged and negatively charged, and then there's a cations, and then cations got attracted with the negatively charged on the layer. And this, by this way, you can exchange it from even from the lanthanides and D block elements and different elements, and this will exchange will generate a
Hello, sir. Is there any network issue from your side?
Which can be utilized for Is there some background sound? Somebody asking anything?
No, sir, right. It's now audible.
I don't know what is the issue coming up. Okay.
It's okay, sir. It's okay. Now you can continue.
All right. So if you can see the negatively charged the clay particles you are having, which is negatively charged here because of the broken edges, and now you have take the water, clay uptake the water, and then it show its, it change its property and holding the more water. So this type of system are important for environmental applications, particularly when you want to cultivate the, certain crop in the desert, where the desert can, because water uptake is very poor, so you can increase the water uptake by changing the mineralogy of a sand or a clay so that it can be cultivated. And we have successfully done, we have successfully improved a lot of crops across the Western Rajasthan just by improving the clay mineralogy. And then you can, this is like a fundamental, how this taking up the clays. So you have like water molecule, which is a 105-degree angle, and this particular angle will help, to cover the maximum area of the charge. So the hydration, and everybody understand about this hydration energy, and this hydration energy basically we are controlling by changing the charge on the clay layers. And the clay water interaction is also very important by the hydrogen bonding, because if the water is already exist in the clay and trapped between the layers, it can attract another water molecule through the hydrogen bonding. And this is the ion hydration. So when we say this cations are there in between the clay layers, and then these cations are attracted with the water molecules. So once the water molecule attracted by the anions, the clay layers started going apart from each other, which is called the swelling of the clay. And this swelling of clay is important for the water uptake of the clay. So you can see certain clay can hold the water for many days, like which are the black clay nowadays, which contain a lot of iron and the sodium, and certain clay which doesn't uptake the water for longer time, so they can't grow much. So everybody, so the black clay is much more better for the growing the crops because it can uptake more water. And inside the cation usually have the iron ion, which is can take the many water molecules holding inside, and there's a continuous chain of the hydrogen bonding forms, and this hydrogen bonding chains try to hold the water for longer time in the clay, which is important for a cultivation. And this is the osmotic pressure. This is another way to find out how much clay will be, uptaking the water because the osmosis. So natural clay that you have been see now they come up the natural clay, which is basically Montmorillonite clay, and the one of the form of the Montmorillonite clay is the silicate clay. So this is a silicate clay, oxidic clay, and amorphous clay. And then you can see this different type of clay people are using. The potters are using for making the different type of clay pots and other things, and those are important. Just to understand how they have been entire chemical dynamics they are going to set up while they are making the pots. So all clay cannot be used for making the pots, but certain clay are. And what are those clay that we are going to discuss? So briefly, I would say that I have discussed that tetrahedron is a central metal, which is silica, and there is aluminum, which is tetrahedral and then octahedral. And then they are making a layers. So 2.22:1, 2 tetrahedral sheet in 1 octahedral sheet. And then this is something they are with a single layer, and then 1:1. And then there will be absorbed cation in between that I have discussed before. Now I have the more clarity on this picture based on after this fundamental introduction. And these exchangeable cations are important because these are the exchangeable cations which change the entire property of the clay for a catalytic or environmental applications. See, people have been using this, pots for, cooling the water and other things. And this continues, all those things are very important to understand the clay, because all clay cannot be used for the pots and for matka and other things. But these particular clay are used, and this is used because of the exchangeable cation. And then you get the smell of, different minerals while you're drinking water from used in the matka. And then if you talk about the clay, that if a cation particle is very big, for example, if you want to use a lanthanide, then how to do that? So only thing you can do that you can put a organic material in between, which can like calcium salt or potassium salt, and then you can heat it. When you heat it, there will be blast, and the energy generated will be push these both layers far, and then you can increase a entire between interlayer difference, the D2, like D1, D2, and D3. So like that we have done in the laboratory, all those things, and then we increase the interlayer difference. And then we put the pillars in between of the different metal ions. Once you put inside the clay, it will work like a catalytic reactor inside. Now you can do the reaction in between the two layers and then between the pillars. Once the molecule goes inside, for example, carbon dioxide activation that we have been doing. So carbon dioxide goes inside and trapped between the layers. And after trapping between the layers, it ought to react with the hydrogen in the presence of a transition metal ion. And then you can convert into the methanol. So this is the first one of the technology that we recently delivered to the different people, different industries, where the carbon dioxide can be converted into the methanol using a clay catalyst on the nickel and cobalt. Another, and this is the first technology once we have started working
Hello. Sir, is any issue from your side?
Hello, am I audible?
Yes, sir. Now it is audible.
No, not at all. Okay, my international connection partly is 1000 Mbps speed I'm having. So it's a lane connection, so I shouldn't think there's an issue here, but it's all right. Okay, so squalene is usually get from the sark liver oil, and the squalene is used for the expensive lipstick and pharma applications, particularly those if you might have heard about the name of the Victoria's Secret and different type of lipstick applications or for ointment, because it's non-irritating, and the only source is the sark liver oil. And this squalene is also important ingredients in the corona vaccine development also. So before we have developed this particular procedure, the most probably the squalene is used from the sark liver oil, and the sark liver oil is, and then thousands of sarks are killed every year just to get this oil out for the various applications for the And so we have started working on it, and then we have developed a much more application and much more standard catalytic process. And Estelle Ladar company is producing around 5,000 liters squalene with our process nowadays, which we have transferred. And then if you can look for the squalene, you will find a lot of information on how important this particular molecule is, because of it's a non-allergic and cosmetic material. And this is, the catalytic characterization. You can see that how this nickel and platinum and palladium is basically, when you take the XRD, you will find that the squalene molecule go and sit on a PT palladium 111 new facet of the crystal. And that is basically responsible for a high activity. And the clay provide a special arrangement to only grow the PD111 selectively after chemical processes. And then the good part is that this is 100% conversion. There's no side product, very selective. And then this is the first clay paper that we have published from our laboratory, and which have been on the cover page. And this is also a patented process. Another issue that we look about that the biomass to transport fuel using Rajasthani clay, and then we have looked for that can we develop a transport fuel, a hydrocarbon using the biomass. And then what is the issue with the challenge with the biomass, that you can converting to biomass to hydrocarbon has been very, very challenging because of high temperature requirement and many other things. But we are able to do this process using a Rajasthani clay with very low temperature. We are able to do around, you can see that cobalt clay we have taken with the 6% loading and less than 300-degree temperature, around 260-degree temperature, and with greater than 99%, and then nowadays this has been using, this technology has been using by BPCL and British Petroleum for 30% blending in the petrol with this technology. And we have been using the various biomass, including the algae oil and agriculture husk and many other things. And this was when we have published this paper in ACS Sustainable Science, and it's been patented also. So it's an excellent hydrodeoxygenation catalyst. And after that, we started looking for, this is some of the glimpse I have given. There are many more applications we have explored. The environmental remediation. The clay we have developed in such a way that we have reduced the, in the clay we have reduced the band gap. We have do the band gap engineering for the clay so that we can clean the water. So if you can go look into that in Rajasthan, particularly in Jodhpur area, you have a lot of textile industry. So it's in Jaipur and in Badmer and various places, and treatment of this water, textile water has been very, very challenging. And also, not only this, we have done it from the south with various dye industry in the south. So we wanted to develop something which is low cost, which is based on clay and can be clean the water. So we have make a photocatalyst from the water for treatment of water. And now I'm happy to say that around 4 mld water has been cleaning in Tamil Nadu and in Jodhpur, Rajasthan, using this particular technology when we are using the clay as a photocatalyst. So what you have to do, you can take a clay and then you mix in the water, which is the dirty water, or you can say this, with the water which contain a lot of dyes, and it will absorb, this clay absorb the sunlight, and then generate a nuisance oxygen and the electrons, which can decompose the dye, and the water is completely clean. So we have all parameter of the water, and the water can be reused. It's very, very simple procedure and can be done in a large scale. Apart from that, we have used the clay composite for the catalytic converters and lithium-ion batteries, and then water treatment and purification. A number of applications we have explored. So some of the glimpses I have given you. And then there had been, various, media coverage on this particular different type of technology that we have developed. And then if you want to go through, there are more news articles that you can look into. And this is my team, and this is the funding agencies that I'm getting. I'm blessed with a very good research team at IIT Jodhpur. I'm blessed with a lot of
Last one. Thank you, sir, for your very knowledge-sharing talk about the Rajasthani clay and its application for environment and energy, how the clay can be used as catalytic converter in water purification and in batteries. Production of squalene from Rajasthani clay, which finds application in cosmetics and pharmaceutics, is a great discovery. Clay-based solid lubricant can reduce the wear down of industrial machine in a good temperature range with very low friction is very useful for industry. The catalytic process using Rajasthani clay converting bio oil from organic waste into transport fuel is also one of the good discovery. Thank you, sir, for giving your valuable time and sharing your knowledge and environment concern very effectively. It is worthwhile to say here that माटी को सोना बना रहे हो आप. Thank you, sir. Thank you, sir.
Thank you.